Absolute value equations. Objective 1, to solve absolute value equations. Let's start by looking at the number line, where any real number corresponds to a point on the number line. So the number 0 corresponds to this point. And let's take a look at the positive real number 5, which is a distance of 5 units from the origin. Now, -5 is the same distance from the origin. -5 corresponds to a point that is also 5 units from the origin. And so the 2 points at -5 and +5 are equidistant. If we generalize and say that x is a positive real number, and its opposite would be -x, both x and -x are a distance of 5 units from the origin. If we were to solve this equation, the absolute value of what number x equals 5, well, then there are 2 solutions for x. X can equal +5, or x can equal -5. Number 1, if a is a positive real number, and if u is any algebraic expression, then the absolute value of u equals a is equivalent to, and the symbol for is equivalent to is a double-headed arrow. U, which is called the argument, is equal to a, or u equals -a. Again, u is called the argument. That's the expression inside of the absolute value bars. Number 2, when solving absolute value equations, the first step is to isolate the absolute value term and have a coefficient of +1. Number 3, solve the equation absolute value of argument or expression 3x minus 1, subtract 5 equals -3. Step 1, isolate the expression containing the absolute value. So we'll add 5 to both sides of the equation. So if we write out every single step, we have absolute value -5 plus 5 is equal to -3 plus 5. So then we have absolute value -5 plus 5 is 0 is equal to +2. Step 2, rewrite the absolute value equation as 2 equations and write the equivalent OR statement. Argument equals +2, or argument equals -2. We also call this a compound OR statement, which means 2 statements with the connector OR. So now we solve these 2 equations. We add 1 to both sides on the first equation. Then we have 3x equals 3. And divide by 3 on both sides. We have x equals 1. On the second equation, if we add 1 to both sides, then we have 3x is equal to -1. Divide by 3. So the second solution is -1/3. Step 4, check or verify the solution. Substitute your solution into the original equation to see if we get a true statement or a false statement. So let's verify the negative 1/3. We have absolute value of 3 times negative 1/3 minus 1. Absolute value, subtract 5 is equal to negative 3. So inside the absolute value bars, 3 divided by 3 is positive 1. So negative 1 subtract 1 is the absolute value of negative 2 minus 5 is equal to negative 3, which becomes positive 2 minus 5 equals negative 3, which is a true statement. Just use a capital T for true. So solution set means use the curly braces. The other solution, after verifying it, is going to be positive 1 along with negative 1/3. Number 4, if we have absolute value of u equals absolute value of v, this can be solved, and this equation is equivalent to, double-headed arrow means it's equivalent to, argument u equals argument v, or argument u equals negative v. Additionally, outside of the absolute value bars, there's a coefficient of positive 1. Not always, but that's what we want to have. Number 5, solve the absolute value equation. 3 times the absolute value of y minus 4, add 4 equals 16. So we want to isolate this absolute value term, get it by itself by subtracting 4 from both sides. So we're going to minus 4 on the left, minus 4 on the right. So we have 3 times absolute value of y minus 4, and 16 minus 4 is 12. We cannot distribute the 3 over the absolute value bars. That would be incorrect. So now we want to get the coefficient on the outside, the 3, to become a 1. So we'll divide by 3 on both sides. So 3 times absolute value divided by 3 is equal to 12 divided by 3. So now we have absolute value is equal to 4. This can be solved by writing the equivalent compound OR statement. Argument equals positive 4, or argument equals negative 4. So for the first equation to solve, we'll add 4 to both sides. So y equals 8, or adding 4 to both sides, negative 4 add 4 is 0. So the two possible solutions are 8 or 0. Solving equations by factoring and using the zero product property. The zero product property says if a product of factors, a times b equals 0, either a equals 0 or b equals 0, or both could equal 0. And this is an equivalent statement. A second degree equation is also called a quadratic equation. And a quadratic equation will have a first term or leading term, ax squared. So a is the leading coefficient. Exponent is 2. This is the quadratic term or the leading term. Then is the linear term or first degree term, coefficient of b. And then there's a constant c, which is a real number, and set equal to 0. This equation is in standard form, as it says in number 3, which means we have exponents that are in decreasing degree order. And set to 0, set equal to 0. Number 4, solve the quadratic equation. 2x squared minus 3x equals 2. Step 1, write the quadratic equation in standard form, set to 0. So we'll subtract 2 from both sides of the equation. And we get 2x squared, the leading term, minus 3x minus 2 is set equal to 0. Step 2, if we're going to use factoring, and in factoring, we look for the greatest common factor of the 3 terms on the left side, and the only common factor is 1. So let's see. If we use trial and error method, which is reasonable because these are small numbers, the leading term, 2x squared, is the product of 2x times 1x. And when we factor the constant minus 2, we do not want to put the 2 in the left binomial and the 1 in the right binomial, because then the left binomial would have a common factor of 2, but that's a contradiction to the statement that the greatest common factor is 1 in step A. So let's reverse those two numbers. I have the 1 on the left, 2 on the right. So now, when we think about foiling, first terms, outer terms, inner terms, and the last terms, on the outside product, or distribute 2x times x, you get 4x, and the inner product is 1 times x. Since the middle term is equal to negative 3x, we have to have a negative 4 and a plus 1. And to get negative 4x, we need a minus with the 2 and plus with the 1. And then plus 1 times minus 2 is negative 2, so everything checks out. So factor and check, and then set each binomial factor equal to 0, and solve in step 4 the two equations. So 2x equals negative 1, and when you divide by 2, we have x equals negative 1/2, or x equals positive 2. Now, the traditional check is to substitute each solution into the original equation, or in step A, with the equation set equal to 0, we have another check called the sum of the roots method for checking, which goes like this. If A is the leading coefficient and B is the coefficient of the linear term, so in this example, A is 2 and B is negative 3. So the minus is going with the middle term, because you consider standard form, which is only addition, no subtraction. So B in standard form is negative 3. So another way to check is called the sum of the roots method for checking. Sum of the roots. Roots is another word for solutions. Method for checking. If we represent the roots by x sub 1 and x sub 2, and we add the two roots, the sum of the roots, if the two roots are correct, is going to equal negative b over a. So if we add negative 1/2 plus 2, that should equal negative b, which is negative 3, divided by a, which is 2. So on the left side, that's the same as 2 subtract 1/2, which is 1.5. And the right side is positive 3 over 2. And this statement is true. 1.5 equals 3/2. So that checks both solutions at the same time. So the solutions are negative 1/2, comma, positive 2. Number 5. To solve this equation, the left side is already in factored form and it's set equal to 56. We're going to multiply the left-hand side. You might multiply with FOIL since these are two binomials, or you can multiply with any method that you know. Let's go with distributing x times the binomial on the right, and then minus 2 times the binomial on the right equals 56. Keep multiplying. X times x, x squared, minus 3x, minus 2x, plus 6. And let's subtract 56 to set this quadratic equation to 0. So we have x squared minus 5x minus 50 equals 0. We're going to write the equation in quadratic form, which it is because it's in decreasing degree order and it's set to 0. So we're going to try factoring and solving. Now the greatest common factor is 1. So we're going to go right into product of two binomials and factor 50. Now 50 can be factored in numerous ways, pairs of factors of 50. Well, first let's go generally with bigger numbers. Let's go 1 to 9. So I have 1 times 50, 2 times 25. 3 is not a factor of 50. 4 will not divide 50. 5 times 10. Since 3 is not a factor, 6 cannot be a factor. 7 will not divide 50. Since 4 is not a factor of 50, 8 is not. And since 3 is not a factor, 9 is not. So the two integer factors of 50 that we want to use are 5 and 10. So 5 times 10 is 50. And then you would figure out the signs, plus or minus, minus, plus. Another way to do this is to use what's sometimes called the box method. Some people call it the X box method. So negative 50, put that number in this top triangle, and b is negative 5. And we want to find two integers that multiply to give you negative 50 and add or subtract to give you negative 5. So you think about it, you do this list of pairs of integer factors, or just do some mental math, and you come up with 10 times 5, but to get negative 50 as a product and negative 5 as the sum, we're going to need a negative 10, positive 5. So minus with the 10 and plus with the 5. And when you multiply it out, you do get negative 50. So either x plus 5 equals 0 or x minus 10 equals 0. And then we just continue solving. X equals negative 5 or x equals 10.